Good morning, pre-calculus. All right, today's video deals with the second section of chapter 12. And today we're going to look at some techniques for evaluating limits. Now, the last section, when we evaluated limits, we did it by the table way. We also showed you the graphical way by looking at it graphically. And then we also did what is called direct substitution. So once again, you're probably saying, what's the significance of this? Well, I really don't want to tell you now because we don't want to spoil the learning of calculus. But what we're doing is we're taking a function and we're taking a value of x and approaching it to see where the limit is. And in this case, it's going to be what the y value is. Now today we're going to look at section 12.2, and we're going to look at some other techniques for evaluating limits. And the big question we want to ask ourselves is, how do you evaluate limits that cannot be solved through the use of direct substitution? Now again, this will be definitely shared in a calculus class. I always try to do direct substitution first, but if that gives you an indeterminate value, then you have to go and find another technique. Now there are two. Well, we've already showed a couple yesterday. Another thing I really want to encourage you guys is to really get to use your calculator and the graphing part. So one technique is taking the function you have, graphing it on your calculator, and look visually to see what the limit is as x approaches a certain value. Okay? But what I want to focus on today is the algebraic techniques. So in these algebraic techniques, there's going to be a lot of things that we're going to bring back to memory. So I got a few examples to show you, and then we'll let you guys try some examples in your homework. Okay? So here we go. The only way to do that is by example. So here is our evaluating the limit of this function. So we want to find the limit as x approaches 2 of this particular function. Well, we already know that if we do direct substitution, if I let x become 2 here, we get a division of a 0 here, so that is indeterminate. We can't really determine what the function is. So that's why I put a question mark here. So we have to go and do a different route. So we're going to do everything algebraically, okay? Now I think I did an example somewhat like this in the last section, but we're going to do it again. So first thing we're going to do is you're going to take your right-hand side, take your function, and we want to graph the numerator and your denominator. So we did this here. If I graph x squared plus 2x minus 8, what are the factors of negative 8? Whose sum is positive 2, and we know it's going to be positive 4 and negative 2. And by doing that, okay, we'll talk more about this at another class. We can see that the binomial factor of x minus 2 gets removed because of cross-canceling. And all we're left with is x plus 4. Now when we get to this stage, okay, we are now can easily plug in our value of x in here. We can now do direct substitution. And our direct substitution in this case, again, is going to be 6. So in other words, if we were to look at this function right here, and if we were to graph it, okay, whether we graph it from here or from here, we're going to see that it's a linear function. Now again, as a quick way, if we were doing this graphically, here's your x-axis, here's your y-axis. We know that we have a y-intercept of 4, and we also have a slope of 1. So I know that this graph will look like this. And once again, I'm just not making this super accurate. As our x approaches 2, so if this is 1, x is 2. Now once again, as x approaches 2 from the right side, and as x approaches 2 from the right side, we will notice that right up here, we can see based upon this example, our limit will be 6. All right, this has a lot of significance. We'll talk about that when you get to calculus, okay? All right, so let's look at another one. Look at number 2. Some of these get a little bit more complicated, but once again, we're just doing the algebraic techniques. Here we go. We have the limit as x approaches 2 of this particular function. Once again, I could let x become 0 in the numerator. I know I'm going to get it. I'm sorry. Let x become 2. I know my numerator is going to be 0, and if I let x become 2 in the denominator, I'm also going to get a 0. So we can't use direct substitution because we get an indeterminate value. So what we got to do now is do some algebraic techniques. Now what I'm going to do is we see that the denominator has 4 terms, so we have to go and use the factoring techniques of 4 terms, so we have to do the grouping method. And I'm not showing I'm just showing as much as I can. Group the first 2, group the last 2, and then you will see from this part right here, again, we can cross cancel, and we see that we'll have 1 all over x squared plus 2. And from here, we can do direct substitution. So we can let x become 2. So 2 squared is 4. 4 plus 2 is 6. So we found now that our limit is 1/6. That's a pitiful 6. It is 1/6, using nothing more than our algebraic techniques. Okay. Now again, these are relatively simple ones. It involves mostly factoring, but let's go a little further. We got to go and do a little bit more of a medium problems. Okay. Here's our next one. Again, once again, we could have done this one graphically. Again, I'm doing it algebraically. You're more than welcome to do it algebraically. It doesn't bother me. Here is, we want to find the limit as x approaches 0 of this particular function. Well, we already know if we were to do a direct substitution, we would get a 0 divided by 0. So we have to do another technique. Now, if you look at this one, again, our goal is to get this function in a way that we can do direct substitution. So if you look at your numerator, we're going to have to do a little bit of rationalization. So I'm going to rationalize a numerator. I know typically when we do functions, we have to rationalize the denominator, but in this case, we're going to rationalize the numerator. So again, if we see this numerator here, this is the square root of x plus 9 minus 3. That's a binomial, okay? And we have to multiply it by its conjugate, which in this case is the absolute value of x plus 9 plus 3. So we have to multiply both the numerator and denominator by the conjugate of the numerator. And after this is just straight up FOIL method, and I'm going to leave the denominator alone. Again, remember now the numerator is a product of a sum and difference, which we know that when we have a product of a sum and difference, we get a difference of 2 perfect squares. So in other words, if we square the first term, we get x plus 9, and if we square the last term, we get 9. Simplify a little further. We simplify the numerator. Okay. And then now in the denominator, in the denominator, okay, I need to put a parentheses around this because I just saw a little tiny mistake. Put a parentheses around that. We can cross cancel the factors of x. Now we've got it set up so we can do direct substitution. So we'll let x become 0. We know 0 plus 9 is 9. The square root of 9 is 3. 3 plus 3 is 6. So our limit as x approaches 0 of this particular function is 1/6. Okay? That is another example doing algebraically. All right, let's try another one. Here is another function. We have, in this case, we want to find the limit as x approaches 0 of the absolute value of x divided by the absolute value of 4x. Now again, this is one of those examples, okay, where as my x approaches 0 of this function, I'm going to get a indeterminate, well, excuse me, we're not going to get a true limit. Because again, once again, when you're dealing with a limit, we're looking at how x approaches 0 from the right and how x is approaching 0 from the left, and seeing where the limit is. Now, if you look at this problem right here, this one's, well, I think it's going to be something like this. Again, I'm not perfect here. Again, this is going to be an absolute value function, and we know that up here, this limit will be different than this limit, so we have to go and do another way, okay? So the next way of doing this is we have to split this up. So the first thing we want to do is look at, well, before I go on, if you graph this, you'll see what I'm talking about, okay? Take the time and graph that, you'll see what I'm talking about. So what we got to do is we got to do it in two parts, okay? Well, what we're going to do is take the limit as x approaches 0 from the negative side. So in other words, if we look at this function, what we're looking at is as our x approaches from the negative side, what will our limit be? And then the second one is what is our limit as our x approaches 0 from the positive side. Then we're going to get two different limits. We can do this, okay? So these little signs up here, that means the first one is we're approaching x, we're approaching whatever our c is from the negative side, and this one is from the positive side. So what we got to do in this case is we have two different problems here. So again, we know in this case as x approaches the negative value, we know that we can do some cross-canceling here. We know our x is going to be negative 1/4. Now again, like I said, if you go and graph these, you will see what I'm talking about, okay? All right, now, the next thing is going to be very important, especially when we get into calculus, is evaluating limit from calculus. Again, I am not going to go into details on calculus, where it came from, how it was developed. We'll worry about that. You'll worry about that when you take calculus, okay? So how do you evaluate a limit? Now, again, what we got to use in this case is this guy right here. This is very, very crucial in the world of calculus. This whole problem, this whole thing right here is called your difference quotient. Now, if you look at it real closely, okay, this is f of x plus h minus f of x divided by h. Now, what this really looks like is the slope formula. Change of y divided by the change of x. All right. Like I really want to talk about how this came about, but we got to have a little bit of something to talk about when you take calculus. All right, so this right here, this whole part right here is called the difference quotient. All right, so to do that, here is our example. Now again, this one right here is, we could have done this one by direct substitution, but we're not going to. So here is our function. And what we want to do is we want to find the limit as our h approaches 0 of this particular function. Now what this is going to do is this is going to give us an equation where we can find the limit anywhere on this function. Again, we don't know what c is. We can say it's as x approaches 17 or x is approaching -5. It doesn't matter. This part right here will help us set up that equation, which is leading up to finding what is called the slope, or which is called the derivative of a function. So what we got to do here is take this and apply it to this. All right, now this is made up. Again, the values of x are going to come along at another time. So it's very simple. What we do is here, everywhere we see an x, we let it become 2 plus h. And over here, we find f of 2. All right, so you take everything and gets plugged into this function. All right, now this part right here, we're going to have to simplify that. Again, 2 plus h squared is 2 plus h times 2 plus h, which gives you 4 plus 4h plus h squared. And then we know that plus 1, that comes from him. Probably should have done this right here. You'll see it a little bit better. I think they showed that in the book to keep things separate. And then this becomes 9. So minus 9. The next thing we do is we neaten it up. Okay, the next thing we do is we keep on and we just keep on neatening it up. In other words, we do a little bit of factoring. When we get up to this part right here, we see that our h's are canceled. And now from right here, we can, this right here is going to be our, what is called the derivative of this function. So again, what we can do now is, I don't know, okay, what we can do now is we can write this now as a derivative. So again, the derivative of this function will be f prime of x equals 2h plus 8. So now what we can do is here, now that we have this, we can find the limit by letting any value of h go in right here. So this one up here is letting h become 2. So again, this one right here, 2 times 2 is 4. 4 plus 8 is 12. So in other words, in this example, as x approaches 2, we know that our y is going to be 12. That's the slope. This is a little bit different. I'm going to let you guys read up on this in your book. You're going to have to get used to this. This guy right here is going to be greatly used until we get into the shortcut of what true calculus is all about. All right, so once again, today in this video, we focused on how to evaluate limits that cannot be solved for the use of direct substitution. Once again, just as an encouragement, always try direct substitution first. If that works, you don't have to do any of these other techniques. The next thing I would really like to encourage you is graph your function. Okay, graph it and look at it and see where they're asking you to find the limit of that function. I want you to look at it. I want you to look at it graphically. Now the algebraic one, again, this one gets a little bit trickier because you got to think in your brain all the different algebraic shortcuts since algebra 1. Again, the big ones are going to be factoring and rationalization. There's a couple others, but we'll worry about that in upcoming sections or maybe next year in calculus. All right, guys, that is section 12-2. All right, one more section. All right, catch you later.